The bomber stream reached Germany like a metal cloud. The engines came first, low and constant, before the aircraft appeared overhead. By the summer of 1944, American formations were crossing the Reich at roughly 20 to 30,000 feet, often dropping their bombs before German fighters could even reach them. Beneath them, Germany was burning. Rail yards, factories, fuel plants, and whole city blocks were taking repeated hits from American bombers. Erich Bachem, the former technical director at Wiesler, looked at it another way. He believed the delay itself was the problem. A late interceptor was useless, no matter how advanced it was. Bachem saw the problem as altitude and time, so he returned to an older idea from his Wiesler years. His interceptor would wait upright among the trees, already pointed at the sky. When the bombers approached, it would launch from a rail like a rocket and climb straight into the formation. It looked less like a fighter aircraft than a guided missile. The slow climb would turn into a violent descent that needed to last only a few seconds. Then a concentrated salvo of rockets would be fired. The difference was that someone still had to sit inside it and be able to escape. However, German officials of 1939 and 1940 thought this was an easy idea to reject. Germany still believed conventional fighters and airfields could defend its airspace. The Air Ministry had little reason to gamble on a manned rocket launched from the ground when normal aircraft still seemed capable of doing the job. Besides, rocket aircraft were considered dangerous, and early programs had already shown they could cost pilots their lives. Guided missiles, on the other hand, weren't considered mature enough since they could not reliably track and hit moving targets. Early guidance systems struggled to maintain control over long distances, often losing the target entirely. 4 years after Bachem's first rejection, Germany no longer had the luxury of normal solutions. The Luftwaffe needed a point defense weapon that could rise before the bombers had already come and gone. That pressure fed directly into the Jägernaut program, the emergency fighter program, which called for aircraft that could be built quickly, launched quickly, and thrown at incoming bombers with minimal delay. German companies answered with increasingly unconventional aircraft. Henkel's P-1077 Julia, for instance, placed the pilot flat on his stomach to reduce drag and shrink the aircraft's frontal profile. Other proposals cut weight, simplified controls, and reduced the training required. Bachem believed his idea went further than all of them. To him, most of the competing designs made the mistake of still trying to be aircraft. His design reduced the machine to the bare essentials of the mission, making it considerably cheaper. Adding to that, it did not need to circle for position or to make a long climb through empty air. Most of the climb would be handled by automatic control, and the man inside would be needed only at the end, when the formation filled the windscreen, just as the rockets had to be fired. The Air Ministry was not convinced. Even with Adolf Galland, the Luftwaffe's General of Fighter Forces, reportedly supporting development, the Reichsluftfahrtministerium, or Ministry of Aviation Technical Office, viewed the concept as unorthodox and difficult to fit into the existing emergency fighter requirement. According to them, the aircraft was crude and did not fit cleanly under any branch of control. It was too much like a missile to be treated as a normal fighter, and too dependent on a pilot to be treated as a true guided weapon. So they dismissed it. After evaluations, Julia became the early frontrunner. It had first been considered for vertical launch, but the design later shifted toward a more conventional horizontal takeoff from a wheeled trolley, similar to early Arado AR-234 prototypes. Bachem refused to let his concept vanish. He looked for support outside normal Luftwaffe channels, where the SS was already pushing deeper into advanced weapons. Through political and industrial contacts, his proposal reached Heinrich Himmler. Himmler saw this as a cheap, fast answer to the bomber problem that would give the SS a weapon program outside normal Luftwaffe control. Within 24 hours, the rejection was reversed. By mid-September 1944, the technical office of the Waffen-SS had issued an order for Bachem to develop and manufacture the aircraft at his Waldsee factory. This also gave the project its official designation, Ba-349, also known as Natter, the German word for a grass snake. With the SS backing it, the engineers at Weldsee were no longer allowed to work at the pace of normal development. They had to turn the design into hardware as quickly as possible. However, American raids kept pounding aircraft factories, rail yards, oil plants, and transport links across Germany, making normal production harder and harder to sustain. Aluminum was in short supply. Skilled workers were gone, reassigned, or already tied to higher priority programs. Many factories had been bombed, dispersed, or forced into smaller sites. Production could not wait for better conditions. The SS wanted the project built immediately, so Bachem had to use the materials and labor still available. His answer was to build as much of the aircraft as possible from wood. The fuselage used glued and nailed construction instead of precision metal joints, allowing cabinet makers, carpenters, wooden aircraft specialists, and semi-skilled workers to produce sections in small workshops away from the bombed aircraft factories. The Natter came out weighing roughly 4,400 pounds at launch, which was light for its role, but left the structure at the limit of its strength. Its wings were short, plain wooden panels, spanning about 13 feet. They weren't designed for endurance, just to keep the Natter stable, long enough to reach the bomber stream. At the same time, there was no landing gear. Removing it saved weight, but more importantly, it eliminated the need to land at all. After the attack, the nose was meant to separate, while the pilot and engine section came down under parachutes. The Natter was never meant for long flight. It only had to survive long enough to get to the bomber stream, fire its rockets, and separate. That logic drove the whole design, informing its short fuel supply, bare-bones systems, and wooden structure, leading to very little margin if anything went wrong. The pilot sat in a small enclosed space behind an armored bulkhead and bulletproof glass, protected only for the narrow part of the mission that included the final aim and attack. For everything else, he was sealed inside a wooden rocket with volatile fuel close behind him. Despite Bachem describing this aircraft as reusable, the design pointed in the other direction. It did not treat the pilot as intentionally expendable, but it placed him inside a system with almost no margin for failure. That margin narrowed even further once the engines were installed. The Natter had been planned around the Walter HWK 109509A2, but by the time Bachem needed hardware, Germany could not simply provide the ideal engine on demand. Rocket engines were scarce, production was strained, and higher priority aircraft were already competing for the same equipment. What Bachem could actually get instead was the older HWK 109509A1, the engine already used in the Me-163. This engine could produce up to roughly 3,500 pounds of thrust, but that was not enough to launch the Natter vertically by itself. The aircraft still needed 4 Schmidding solid fuel boosters mounted around the rear. Together, the launch system could produce roughly 14,000 pounds of thrust at the moment of liftoff. The Walter engine gave steady power, but the boosters were what ripped the aircraft off the launch tower. If one of them burned unevenly, came off late, or did not separate cleanly, the whole aircraft could get thrown off balance before the pilot really had control. It got even worse once the actual fuel used to ignite these engines came into the equation. The Walter engine used 2 separate liquids, T-Stoff, an 80% hydrogen peroxide solution, and C-Stoff, a fuel mixture containing methanol and hydrazine hydrate. The Natter carried roughly 140 gallons of these volatile propellants inside an airframe only about 20 feet long. But the 2 liquids had to remain separate until they reached the engine. As soon as they touched, they ignited. Only the plumbing kept the aircraft from destroying itself. Separate tanks, lines, valves, and seals had to keep the fluids apart until the right moment. A failed seal could cause a liquid to flow into the wrong part of the system. Contaminated fueling equipment could trigger a reaction before the engine even started running. One bad hose connection or cracked fitting could turn fueling into an emergency. The crews already had a warning from the Me-163 Comet, which used the same basic volatile rocket system. In one known accident, test pilot Josef Poos lost his life after the aircraft's takeoff trolley bounced back and damaged a T-stop fuel line. The failure forced him to crash land, and the leaking oxidizer entered the cockpit. Even with these risks, the program couldn't afford to slow down to address them. Himmler and the SS needed results, and they needed them quickly. Each failure made it more likely that the project would lose backing to other weapons fighting for the same engines, fuel, and factory space. The Julia, for instance, had become one of the stronger candidates, but it never got past the design stage, partly because the SS had more faith in Bachem's aircraft. The Natter did not enter testing until winter 1944. By December, the SS had become even more involved, and Himmler's support pushed Hans Kammler's organization, the Obergruppenführer, to take a bigger hand in advancing the project. Kammler was neither a designer nor a test pilot. He was an SS organizer, known for forcing weapons programs ahead under intense pressure. Once he was in charge, the Natter was pushed toward deployment before anyone had even proved it could fly. So the first tests stayed as simple as possible. Early prototypes were pulled into the air, behind Henkel HE-111 bombers with tow cables and released as gliders. Once the aircraft had speed, it handled better than expected. Pilots found they could be controlled with ease. However, as the tests moved toward vertical launch, the results began to look less promising. The 4 boosters attached produced more than 10,500 pounds of thrust, over twice the aircraft's own weight, for about 10 seconds. If that thrust was not even, the aircraft could twist or drift before the pilot or control system could correct it. The thrust and burn time at the Schmitting were inconsistent, leading to some units exploding unintentionally. By the end of the testing phase, 16 Natter prototypes had already been used, 8 in glider trials and 8 in vertical takeoff trials. Some were recovered, but many were damaged, lost, or broken apart during testing. Even worse, engineers were still working out the center of gravity to make the Natter work. With the boosters attached, its balance point could shift as far back as 65% of the wing chord, well beyond the stable range of 20 to 30% on a normal aircraft. Once the boosters dropped away, the balance moved forward again to 22%, bringing it closer to that stable range. As a result, engineers tried to compensate. They added large auxiliary tail fins, about 1 meter square, designed to stabilize the aircraft during launch and then fall away with the boosters. They also used exhaust vanes in the Walter engine plume, giving the aircraft some directional control before normal airflow over the wings and tail could take over. However, every fix pushed the Natter farther from the original idea and closer to a deadline that kept creeping in. By January 1945, Himmler himself had lost almost all interest, and other officials wanted engines, fuel, and factory space redirected to more advanced weapons, such as the Me-262 and 263. If the Natter wanted to survive, it needed one full test to work before it slipped down the priority list. At this point, asking a pilot to test it live with the engine installed was impossible. While a normal aircraft could be flown repeatedly until the pilot understood its behavior, the Natter could not be flown repeatedly. A full mission ended with the aircraft breaking apart as designed, and that is if everything worked. Pilots could train on parts of the mission, such as glider flights, classroom instruction, or parachute drills. But there was no way to run the full sequence without risking both the aircraft and the pilot every time. And yet, Bachem found a compromise that pleased Himmler. On February 25, 1945, the test aircraft was finally prepared with the Walter HWK-109-509A1 rocket engine installed. A weighted dummy sat in the cockpit. This was the closest the Natter had come to a real mission. The ignition sequence started, and all 4 Schmitting boosters fired, along with the Walter engine. They generated about 14,300 pounds of thrust. The Natter shot off the tower cleanly. There was no violent roll, no failed separation, no instant crash. After about 10 seconds, the boosters burned out and dropped away as planned. The aircraft kept climbing under rocket power. For once, the most dangerous part of the launch had actually worked. Then the recovery sequence started. The nose section broke away. The dummy pilot came free and descended under a parachute. The rear section, carrying the Vultran engine, also came down under its recovery system. To the engineers watching from the ground, this was the proof they needed. However, when the rear section hit the ground, residual T-Stoff and C-Stoff ignited. The recovered aircraft was destroyed by the same fuel it had carried into the sky. Even so, for a second, that seemed enough for Berlin. The system had worked long enough to justify the next step. At the same time, the Ministry of Aviation wanted the project to move faster. Bachem was being pushed to attempt a manned launch before February was over, and an operational evaluation was already scheduled for April. Bachem believed the aircraft had not yet reached a stable, repeatable configuration, and no pilot had experienced the full launch sequence under rocket power. And yet, on March 1st, despite Bachem's concerns, another aircraft was prepared for launch and fully fueled. This time, the cockpit would carry Lothar Sieber, a young Luftwaffe pilot who had already flown dangerous wartime missions and volunteered for the test. The aircraft was wired to send data back to the ground through an FM transmitter, and a hardline intercom appears to have connected Sieber to the engineers in the launch bunker. Every part of the flight was being watched, measured, and listened to. At around 11 a.m., the Natter was standing on the launch tower, its Vultran engine and 4 Schmitting boosters armed. The sequence began, and the aircraft rose vertically on a huge column of thrust. At first, it seemed stable. Then, at roughly 300 to 500 feet, the Natter pitched into an inverted curve, about 30 degrees off the vertical, while still accelerating. At about 1,600 feet, the canopy flew off. Sieber's headrest was attached to the underside of the canopy. When the canopy tore away, it would have pulled the headrest with it, snapping his head backward nearly 10 inches into the solid wooden rear bunkhead. Bachem later thought Sieber may have pulled back on the control column while under about 3 Gs of acceleration. Either way, Sieber was probably unconscious while the Natter kept climbing. It continued at high speed, now angled far from its intended path, and disappeared into the clouds. About 15 seconds after launch, the Vultran engine stalled. One likely cause was the aircraft's attitude. If it had become nearly inverted at any point, air may have entered the propellant intake lines, starving the engine. The aircraft climbed to roughly 5,000 feet, then began to fall. With thrust gone, the Natter lost speed, stalled, and entered a steep dive. There was no visible sign that Sieber was taking any steps to recover the aircraft. About 32 seconds later, it struck the ground several miles from the launch site. The impact destroyed the aircraft and took Sieber's life. The entire test flight lasted less than a minute. The canopy was found near the launch site with a bent latch tip, suggesting it may not have been fully locked before takeoff. Decades later, in 1998, the remains of one Schmitting booster were found at the crash site, suggesting it may not have jettisoned properly. After the accident, the canopy latch was strengthened. The headrest was moved to the cockpit backboard. Bachem also concluded that the most dangerous part of the flight, the launch and early climb, needed more automation. Before a full autopilot could be introduced, the control column had to be temporarily locked so the aircraft could climb to at least 3,300 feet before the pilot took over. Still, the response did not stop the program. The accident was treated as a technical failure to be corrected, and development continued. Subsequent Natter flights were conducted without a pilot. Pilots assigned to the Natter program did not appear to have been fully briefed on Sieber's crash, as their training continued anyway. After months of rushed design work, failed prototypes, and a casualty, The Natter was finally nearing the moment that could make it all seem worthwhile, an actual launch against Allied bombers. This was its chance to prove the concept in combat. All it needed was one clean climb, one rocket salvo, and one damaged bomber. That would be enough to call the program viable and to ensure they had produced something Germany could still use. And the regime had already picked the day. The Natter's maiden flight would be on April 20th, 1945, Hitler's birthday. A new weapon rising from a hidden forest launch site on that day was exactly the kind of symbol the regime wanted. The deployment was called Operation Crocus. Its launch site was hidden in Hassenholz Wood, in southern Germany, about 20 miles southeast of Stuttgart, and close to the Autobahn running toward Munich. The location offered concealment in the forest, access to transport routes, and proximity to the bomber paths it was meant to intercept. In late February and early March, Organization Todtcrews moved in to prepare the site. These were crews used to throwing up bunkers in emergency fortifications under pressure. In the trees, they laid out 3 launch pads in an equilateral triangle, about 390 feet per side, with each pad built around a square opening for the tower base and a nearby cable pit. 8 men had volunteered for the first operational flights, training for weeks for an attack from above. They had their eyes peeled at the sky, listening for the faintest sound of engines overhead, or looking for contrails above the forest, expecting their launch orders to come through at any second. Instead of bombers, on April 20th, the U.S. 10th Armored Division drove into the Hassenholz Wood. The next day, American forces crossed the Autobahn and moved toward the Natter operational area. At that point, the launch site could no longer be held. The crews had no time to turn the weapon against the enemy it was built for. The group pulled back toward Waldsee, taking what they could and leaving the launch position behind. By April 25th, French forces had captured Waldsee and likely taken control of the Bachem works. Before they arrived, Bachem personnel tried to move surviving Natters toward Austria on trailers. Some reached the Inn region. Others went toward San Leonard im Pitztal. Within days, U.S. troops captured them. Bachem lived to see the war end before his aircraft ever reached combat. The SS had ordered 150 Natters, and the Luftwaffe wanted another 50, but none arrived in time. Around 36 were built, 22 were launched, and not one ever fired in combat. Most were burned, abandoned, or captured as the front fell apart. As a wartime weapon, the Natter failed. It never protected a city or scattered a bomber formation, but the idea behind it did not go away. The Natter was meant to launch from the ground, climb hard, chase down a high-altitude aircraft, and hit it before it got away, with the pilot still inside. Cold War surface-to-air missiles later handled that mission with radar and electronics, with no cockpit. The mission remained. The pilot disappeared.